Welcome to the Rim Break Rodeo. We hope this video helps.
You start by locking scope and resources. Choose model scale, latency targets, and your budget so decisions later are constrained. Once chosen, provision compute, reserve GPUs, networking, and high I/O storage. Prefer CloudSpot if cost matters. Next, assemble datasets, web text, domain data, and aligned instruction pairs, deduplicate and normalize into JSON/TF record. These first steps mean you can run experiments immediately, so validate a tiny pipeline end-to-end before scaling up. Now you build and train. Choose a transformer variant and tokenizer that match your token distribution. Iterative tokenization tuning reduces OOV noise. Set hyperparameters pragmatically, batch size tied to GPU memory, learning rate with warm-up and cosine decay, and gradient accumulation to simulate larger batches. Implement robust data pipelines, sharded streaming, on-the-fly augmentation, and mixed precision to cut cost. Monitor loss curves and validation metrics continuously so you can adjust schedules and stop before overfitting. Finish by fine-tuning for desired behavior. Use supervised fine-tuning, then RLHF if alignment matters. Validate on held-out tasks and safety checks. For deployment, containerize the model, apply quantization or pruning to reduce latency, and set auto-scaling plus a /B tests for performance monitoring. If issues arise, check for data leakage, label noise, catastrophic forgetting, or hardware OOMs. Recreate minimal repro case and roll back to last good checkpoint. Make sure logs and metrics map to alerts so you can act fast.
Thanks for watching. Consider subscribing if we helped you.